So pests carry diseases. Pests eat our cereal crops. Pests always also damage or contaminate stored food. So this is like rats and mice. So they get into our stored food. This could also be ants. Anything that makes its way into your pantry that you wish had not would count for this. Another thing that pests do is they damage our clothing. So examples of this are like silverfish and moth. Silverfish are actually not fish. It's a type of bug. And then moths. They're also known for damaging buildings, such as termites. And they can also damage or compete with agricultural plants for necessary resources. So something to be aware of is that when we were talking about pests up here, oops, wrong thing. Up here, we were talking about like bugs and animals and stuff like that. Whereas down here, we were talking about plants. So plants can be pests too. So like think about weeds, right? Weeds are considered pests because they are competing for your plants for natural resources. Or if you think about morning glory, which is like the bane of my existence, it actually can choke out plants. Since it's a bindweed, it will grow up and just like choke out the plant itself. It's the most ridiculous thing in the whole entire world. I hate it. So again, quick recap. They carry diseases. They attack our vegetables. They contaminate stored food. They attack and eat farm animals. They damage clothing, damage buildings, bite or sting people. So like bed bugs, mosquitoes, bees, wasps, what have you. And they can also compete for resources of other things. I'm going to scroll up just a little bit, so don't freak out. All right, so down here we have 3 different ecosystems. So looking at these ecosystems, looking at the very first one, so this is before a pest or disease comes by. I'm going to ask a couple of popsicle stick questions really quickly as soon as I make my way back to the front. So in terms of biodiversity and bio-evenness, biological diversity and biological evenness, I want you to tell me, like, explain what the before environment looks like. So this question is going to Lexi. So looking at this environment right here, so we've talked about species evenness and species diversity. So how diverse and how even is this before community?
I don't know.
Okay, so we'll come back to you.
Pretty even.
Yeah, actually, I will take that answer. So if you look at it, it has pretty good species evenness, right? Not bad at all. So that is an awesome answer. Okay, let's talk about species diversity. So this question is going to Bradley. So Bradley, how diverse is this ecosystem? Yeah, the first one. I mean, we're only looking at 4 species, so are all 4 species there? Yeah, so it's pretty diverse, right? Pretty diverse. So this is after the pest or disease. So looking at our species now, how even is our species? So this question is going to Ridge. So, is Ridge? He's not here? Oh, awkward. Make sure I mark him as not here. Alexa is also not here. Cam. So looking at this right here, how has our species evenness or species diversity changed? Where are you, Cam? I know you're here somewhere. There you are. Yeah, so it's a little bit less even, right? Across the board, we can see that it's a little bit less even. But the biggest thing is just that our populations are down, right? So if we look at the picture right here, what color of tree are we actually missing? So this is just for anybody. What color of tree are we missing if we look at the middle picture? The yellow, right? The yellow, oh, that's not yellow, right here. The yellow ones are gone, so you can't see them at all. So now, going to our recovery period, how does our species evenness look now? So this one's going to Madison Johnson. So now that we're going, so we had before to after, right? And now we're at recovery. So how has our species evenness and our species diversity changed from our original? So from here to here, how has that changed?
It's more varied.
Perfect, right? So our species evenness, it's not even at all. There's like not a straight line that we can really draw across the board. And are we missing any species? So looking at the picture itself, are we missing any species that came from our very first population?
Yes.
Yeah, right? So our diversity and our evenness have both really been impacted by having these pests. So pests really have the ability to change up an ecosystem and change up the health of the ecosystem. So pest control methods. When you think about pest control methods, you're probably originally going to think about killing the pest, right? That's like step number one. When there is anything to do with pests, you're going to want to kill them. So the different ways of killing pests are some kind of side. So herbicide for plants, fungicides for fungus, rodenticides for rodents, and insecticides for insects. So that's the very first idea, is we want to get rid of these pests. I know, right? Insecticide. So the pros of using chemicals to get rid of pests is that you have protection of the resources, so immediate protection for resources, and also protection of health. So if those pests are actually affecting humans, then we're going to have protection from our health, like if we're killing mosquitoes, or we're killing ticks, or we're killing fleas or bed bugs or whatever. So you're going to have immediate responses. Two other things that are not written up here that I'm going to write up here real quick. Number one is that it is cheap. So it is really cheap, meaning that it's not going to take a lot of money to do it, and that it's easy. So it's cheap and it's easy. So if we look at just spraying chemicals on a field at a bug or a pest, immediate results, it's cheap and it's easy. But if you look at the cons of this, pesticide resistance through selective pressure. So this is kind of a weird way of saying it, but if we use the same pesticide over a long period of time, how effective is that pesticide going to be as it moves forward? Not effective. Cool. Let's continue with that. Why would it be less effective? Perfect. So we're going to see evolution. So selective pressure right here is talking about evolution. So through evolution and through the ability for animals and plants to adapt and change, the same pesticide is going to become less and less effective. Another thing is that we could possibly eliminate really good animals. So if you are a backyard gardener, I follow the Utah Gardeners Facebook page because, that's just where I am in my era of life right now. There's a lot of people talking about when to spray for pests and like what pesticide to use because there's a big problem with bees being affected. Like we don't want to kill our bees because bees are what allow for pollination, which is what allows for food to grow. So there's going to be elimination of beneficial pests. And then we have toxicity that accumulates and is magnified in a food chain. So I'm actually going to draw that out so you guys can understand that a little bit better. Let me find a blank page real quick. Sorry, I'll come back, I promise. Okay, so is there like a plain blank page anywhere? Oh, wait, come back. I saw it for a second. No, I need to have like a drawing page. Oh, that's okay. I mean, that's just like using your brain and actually like understanding stuff. 10 points to Gryffindor. Okay, so we're talking about accumulation. There are two things we can talk about. We can talk about, hate that. We have bioaccumulation. And we have biomagnification. So, bioaccumulation, biomagnification, sometimes they're used interchangeably, but they are not the same. So, bioaccumulation is where when you are surrounded by a chemical, you're going to accumulate more of it the more you're around it. So more accumulation, the more you are around it. So for example, the more I'm around teenagers, the more I'm going to use teenage slang that my siblings and my parents do not understand. So for example, I told my mom she was the goat one time. And she was like, "What are you saying?" I was like, "You're just the goat, Mom." And she's like, "What does that mean?" I was like, "You're the greatest of all time." She's like, "Oh, why didn't you just say that in the first place?" And I'm like, "Sorry." Also, I told my brother that, like, he had good drip. And he was like, "What are you talking about?" I was like, "Your drip, man." He's like, "What?" Anyway, so do me a favor. Turn to somebody at your table and describe bioaccumulation to them in your own words. I'll leave that up there, but in your own words, describe bioaccumulation. Ready, go. You're just saying random words back there. We're not talking about selective pressure.
No, but that's a good example. Selective pressure is kind of like bioaccumulation because they're actively involved in something they're around.
So what you're saying is bioaccumulation could lead to selective pressure. Okay. Okay, we're going to let the popsicle sticks of destiny choose who's going to explain this in their own words. So this one is going to Vanessa. Okay, what is bioaccumulation in your own words? If your mouth hole is making noise, make sure it's not. Okay.
Something that slowly gets used to something the more that they...
So you're on the right track. So instead of getting used to it, they just accumulate more over time. So the more you're in an area, the more you're going to accumulate whatever chemical we're talking about. So please don't come in late and then make me stop my lesson like 3 or 4 times to make you guys shush. Okay. So biomagnification is different. If we are using an herbicide, so here's our cute little pyramid, right? So we have plants on the bottom, and then an animal and another animal. So if we're using an herbicide, which layer of this pyramid is going to be affected by that herbicide more? So originally, so I like the idea of top, we'll get to the top, but like directly affected by the herbicide, which one's going to be affected? The plant, right? The plant. So let's say that we have a plant here, and the plant, so these are animals, just AN, because I'm lazy at drawing things. So each plant has one molecule of herbicide on it. So these are plants that weren't killed by the herbicide, but they still have the herbicide on them. So let's say that we have a bird. So how many plants is this bird going to have to eat? So that's a beautiful plant. Guys, look, art is my passion. So how many plants is this bird going to need to eat to survive? So we'll say 10, right? So if we have 10 plants and each plant has a speck of herbicide in it, how many specks of herbicide is the birdie going to get? 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 specks. So now we have a snaky boy.
Why isn't the bird the snake? Why is the snake eating the bird?
Because in my world, snakes eat birds, okay? So how many birds is a snake going to have to eat? 10. So how much herbicide is the snake going to get? 100. Right? So it goes from 1 to 10 to 100. That is biomagnification. So biomagnification states that the higher you go in the food web, the more concentrated a pesticide is going to become. All right, so as soon as you're done writing that down, I want you to turn to somebody next to you and describe biomagnification. Oh, that's so embarrassing. That is. Here, let's get in. I'm going to stay behind you.
Biomagnification.
19. Yeah. Does not exist. As long as I get it before I leave on the 21st, you're good to go. All right, let's see who's the lucky one who gets to explain biomagnification. Let's find somebody who's actually here. Joel, biomagnification, what is it? In your own words.
The higher on the food web it goes, like the higher concentration.
Perfect. Yep. So the higher on the food web you go, the higher the concentration you're going to be because you eat things below you. So what's the big difference between bioaccumulation and biomagnification? So this question is going to go to Addie. So what do you think is the difference between bioaccumulation and biomagnification? Perfect. So the first one you are accumulating more because you're around it more, where the second one you're getting more concentrated. So please be aware of this because the AP test likes to ask questions about both of these together. So make sure you understand the difference between biomagnification and bioaccumulation. So since pesticides are not always the best answer for pests, we have come up with something called an integrative pest management system. So what an IPM is, it's a combination of methods to effectively control a pest species while minimizing the disruption to the environment. So because we know that pesticides, while they are cheap and easy and effective, they're not always the best option for the environment. So what we need to do is we need to talk about all these other different things we can be doing along with using pesticides, herbicides, rodenticides, and whatever to make sure it works better. So some of the things that are going to be in an IPM, and we'll talk about each of these in depth the next slide down. So the first one is cultural control. So cultural control basically is just educating the masses so that they understand what they can do to help. So for example, I used to work at this place called the mosquito abatement when I was in college because they paid you a heck of good money and you would just work in the summertime. And so my job was I rode a bike for 8 hours a day and I would find storm drains and I would find mosquito larvae and treat it. I would kill mosquito larvae so there'd be less mosquitoes during the summertime and we would have less West Nile virus. So it was a great job. I got really awesome tan lines and I listened to a bajillion audiobooks. So part of my job too is I would go to like the summer fairs that people have, like Draper Days and like the Utah State Fair and things like that. We would go and we would educate the population on like ways that they can help reduce mosquito populations, like dumping out dog water dishes or cleaning out kiddie pools because mosquitoes lay their eggs in water that's still. And so the less still water you have, the less mosquitoes you're going to have. And so that's a cultural control, something that individuals can do to stop the population growing. The second one is a physical or mechanical control. So physical or mechanical control, think about weeding. That is a physical or mechanical control. You are physically removing the pest, right? So this is really awesome because it has no chemicals. It's really easy to control. However, it's very expensive and it takes a really long time, which is not great. Next, we have biological controls. Biological controls is where you take native predators of whatever you're trying to kill and you introduce them into the population. It's kind of expensive because you do have to breed the predators you're looking for, and also you can't really control natural things. Like if you put predators out there, there's no guarantee that they're only going to eat what you want them to eat. They could affect the food web in a different way. And then chemical controls is what we just really talked about. So the idea is that an IPM reduces the risk that pesticides pose to wildlife, water supplies, human health, and minimizes disruption to the environment. But it can be very expensive. So that's the biggest problem with IPMs, is that it can be really, really expensive. So it's the best thing to do, but it costs the most money. All right, so here is a little bit more information on biological controls, cultural controls, physical. Don't you do this to me, screen.
Oh.
I know we were fighting last class period. Oh, and you just disconnected from my iPad. Don't you do that. You son of a gun. It was really bad last class period because I had my grade book up, and so people were literally seeing people's grades when it stopped. And I was like, no, don't look at the screen. It was terrible. It was definitely a teacher fail. And connect. There we go. Okay, so here are all of the different controls. We have biological controls, cultural controls, physical, mechanical controls, and chemical controls. We talked about each of these. You're welcome to put them in your own words if you want to. So again, biological controls is the use of natural enemies. Cultural controls are just practices that reduce pest establishment. So honestly, if you wanted to, just write like the first 4 words of every single one. So biological controls is the use of natural enemies. Cultural controls are practices that reduce pest establishment. Physical controls is to directly block pests out. And then chemical controls is the use of pesticides. So let me highlight those for you guys. So practices that reduce pest establishment, barriers to block pests out, and then chemical controls is just the use of pesticides. So one thing I forgot to mention when we were talking about biomagnification, and I'm only going to talk about this because I know that the AP test or one of the tests that you'll take will talk about it, is that the biggest example of biomagnification is bald eagles. So there was this chemical called DDT that was used to help with pests, and through biomagnification it would find its way to the bald eagle. And since the bald eagle is a bird, birds hatch their eggs. The chemical that got in the bald eagle, DDT, made their eggs super, super brittle so that when the bald eagle tried to hatch their own eggs, they would squish the eggs and they wouldn't be able to reproduce. And so through biomagnification and through the chemical DDT, which again was a pesticide, the bald eagles almost went extinct. So that's why we need to make sure we're looking at IPMs and we're using the most effective way of taking care of our environment, which leads us to sustainability. So what is sustainability? Sustainability is living on Earth in a way that allows us to use its resources without depriving future generations of those resources. If you're following along on the guided notes, we should be on like the dark pink page now.
Wait, did we already write this down?
We have not already written this down, no. So the idea of sustainability is to make sure that our environment is not depleted. So last time when we were teaching, well, when I was teaching and you guys were listening, Joel asked me, why do you still teach this class? This class is so depressing. And the reason that I still teach it is because I want people to be aware of it so they can be more sustainable. So we can make sure that we have stuff for future generations. Because the first step to understanding and fixing a problem is being educated about it. So things that affect sustainability, number one is diversity. So understanding how we are affecting diversity and how diversity is important for the ecosystem. Because the more biologically diverse an area is, the more healthy it is. Number two is describing and understanding food production. So we've talked about food production. That was our longest unit, longest part of this unit, I guess I should say, where we learned about how plants take less area and less water than meat does, and so it uses more resources. The different ways that we raise our meat, how it affects us, and how it is sustainable or not sustainable. And we also talked about soil conservation and agricultural practices. So understanding that goes into food production so we can make the best decisions there. Average global surface temperature really comes from understanding CO2 concentrations. So understanding how we are using more CO2 or we're using more fossil fuels that produces CO2, which leads to average global surface temperatures changing, because global surface temperatures changing is going to affect biological diversity. It's going to affect food production. And so that really plays a big role into all of this. Then we have human populations, which we did not talk about this unit, but we talked about that last unit. So the bigger our population gets, the more resources we're going to need to use, and the more sustainable we're going to have to be. And then last but not least, resource depletion, being aware of what resources we're using and how quickly we're using them, which can lead to a depletion of those resources. So the goal of sustainability is to have sustainable yield. So what sustainable yield is the amount of renewable resources that can be taken without reducing the available supply. So those that have the notes printed out, you already have a beautiful diagram that looks like this. If you do not have the guided notes that you're following along, I would love for you to draw this in your notebook. So the idea of sustainable yield is that we want to be in the zone of optimal effort, which means that we are using our resource at a place where we are getting the most bang for our buck, but we're also not damaging the ecosystem. So if you think back to our overfishing simulation at the very beginning of this class, this unit, if everybody would have just taken 10 fish at the very beginning, we all could have lived happily and had as many fish as we needed to survive. But because we decided to be a little bit greedy, we got shoved into this section, the zone of overfishing or the zone of overutilization. So we overused our resource, which meant that we could no longer sustain ourselves. Yeah.
How is underutilization bad?
Ashley's gonna get to that. Underutilization, in my opinion, is not bad. It doesn't harm the environment whatsoever. I mean, it harms us, ? Because we're not using it to our full potential. But it's not harmful.
But what if it's like fish and it's like they're overpopulating?
So that could be a problem, yeah. So if we're using it in a way that is harmful to them, but I mean, if we have overpopulation, we're just gonna have their predators are gonna get more numerous, and so nature should take care of it. But if it's a place where there's no predators, then yes, it could definitely be a big problem. Good question. Yeah, so the big idea of sustainability is just understanding what resources we can use and at what limitations so that we can make sure that our environment is still around and our resources are still around for those that are going to use them in the future. So are there any questions about IPMs and sustainability?